So last time we talked about um, the slope of a tangent line and how that, as you get closer and closer to that point, you can see what the slope is of the graph at that point. And even though the slope is constantly changing, which is the idea that's really important, slope is constantly changing. You can not only estimate, but you can actually calculate the change at any one point. Changing. Ooh, there. Slope is constantly changing. So we're going to go and talk about that slope because it's rather important. So you have a line, a tangent line of this, let's see, let's make it simple. So you have I'm going to write the tangent line first so that 1, 2, 3, 1, 2, 3. So you have some function here, and man, I drew it over here, but this is 1. Okay, I'm sorry for all you OCD people out there, myself included. I know this will bug you to the end of time, but just live with it. So the point we're looking at is right here, and here's our tangent line. And so hold on, I've just discovered there's a better way to do this. I'm sorry I keep changing, guys. I know it's difficult to listen to a teacher who doesn't know himself or herself or themselves. I never know what pronoun to use with myself these days. But so instead of trying to draw the function with the tangent line, I'm just going to draw the tangent line because as we've noticed in this function over here, once you get super close to a function and its tangent line, you find that the slope of the line and the slope of the function are just about the same. So we're going to, so this is infinitesimally small, close to a point, x equals 1, y equals 1, just for simplicity. Okay, so what you're going to do is you're going to find a point over here and find a point over here that's the same distance. So this is the same distance from this point as it is from this point. So yeah, these points are equidistant around this one right here. And then the slope of that line would be the rise over run, as you've heard it called. And we're just going to call this something different this time. We're going to call the rise change in y, and delta is just change in it. It means a change, so, or a difference, or an amount that has, yeah, the amount that's changed, or the distance traveled is another way you can think of it. So that's going to be delta y, and this is going to be delta x, or the change in y and the change in x. So, well, what is slope? What is the slope of this line? Well, it's going to be the change in y over the change in x. And that's pretty simple, right? So, and knowing these 2 points, let's say, I'm trying to debate whether I should use numbers that are far off from 1 or numbers that are much smaller and closer to 1 but with decimals. I think I'm going to pretend this function is extremely large and that this is, okay, we're going to change this from 1, we're going to make it 3. I'm sorry. Can't make it simple. I have to make it complicated. Just bear with me. I mean, you guys wanted me to do a video, and here's my video. So I apologize if it's hard to understand. Like I said, if you have questions, you can come and ask me. And then, so this point is 3, this point will be 2, there's 1 over here, 1, 2, and this point here well, let's say it's 3.5. I know I said wouldn't use decimals, but that's not a tough decimal to use. So you have right here, you have at this point here is 3, 3. 3, comma 3, and this is not interval notation, this is a point. The point is x equals 3, y equals 3. Here, x equals 2, I'm sorry, I wrote it out. X equals 2, y equals 2. And here, x equals 4, y equals 4. I did it again. My goodness. Okay, so you found that this point here, the change from this y value to this y value is the change in y, and the change in this y value, or this x value to this x value, is the change in x. And remember what we talked about it being infinitely small or infinitesimally small? Well, that's what this change of x is going to do, and that's why we take the limit of the slope of the line and not just the slope. Because we're taking the limit of a secant line that's infinitesimally closer to that point, because a secant line, why? Because it intersects the graph at 2 points, and why the limit? Because we're zooming in infinitesimally closer to that point, so we can get the best estimate, or the best explanation of the behavior of the graph at that point, in this instant in time. And so let me pause it real quick so I can think of what I'm going to say. And I'm sure this all looks very familiar to you, because you've already taken, most of you have already taken algebra. If you haven't, I recommend you drop the class as soon as possible, if it's not too late already. And if you haven't, and if you have, then, which most of you have, you'll know that the slope, the formula for a slope given 2 points is the same as this here, which we'll expand this. We'll say that delta y is equal to y2 minus y1. And the delta x equals x2 minus x1. And this here we'll call x2, and here we'll call x1. This is x1 and that's x2. So you just basically plug in the x and y values of these 2 points and you get that. And so what we're going that's basically all it is. And when we look at the formula for the derivative, that's all this is. But it's taking the limit as this denominator here approaches 0. We can't take the limit at 0 because then it would be undefined. So we're going to take the limit as the change in x, or delta x, approaches 0. And that's important because we're getting super close to this point. I know I'm repeating myself a million times, but I want to make sure you guys understand that as you get closer and closer to that point, taking the limit of those 2 values around that point, you're going to get the slope of the line. And the slope will be the infinitesimally small change in x, I should say the infinitesimally small change in y over the infinitesimally small change in x, because we're getting infinitesimally closer to that point. So in its most simple form, that's what the derivative is it's a slope formula for a line, the slope of a line, the tangent line. But the problem is, a tangent line only intersects the graph at 1 point. So you don't have 2 points to work with, you only have 1. And there's no way you can find the slope of this unless you're an incredibly smart genius without having another point to go off of. And so this is where this formula becomes so useful, because it'll tell us the slope of that line, because we're going to take the limit as the slope of the line, or as the secant line distance of the 2 points from x becomes closer and closer to 0. So now we'll go into the formal definition in the next video. Getting pretty long here.